Eyes to the ground, no one cares. Empty streets, whispers bite. Lost my way in the dead of night. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. Gonna find my way back to the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. The shadows laugh, but they don't own me. I've burned before, now I'm free. Fire in my veins, ashes in the wind. I lose, I learn, I begin again. Rock bottom hit it, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no change, no lie. Gonna find my way back to the top.
All right. Good morning, good evening, good afternoon. This is Mike from unknowntech.io, and welcome to the Architect Podcast. So this is episode 16. Thank you for joining me. I know some impromptu, wasn't really scheduled. I actually just did this morning after I went out and shoveled a bunch of snow. I hope you all had a great holiday, Christmas for those who celebrate Christmas. For those who celebrate other holidays, I also wish you happy holidays as well. And I just wanted to talk about what we're going to do today. So I originally put out that we're going to be deploying the Nvidia video search and summarization platform on the Nutanix AI platform. And actually, I have to call an audible. I actually had an issue with one of the video or the GPUs in my node. So I need 3 GPUs at minimal to do the VSS portion of the event viewer portion of the video search and summarization piece. And I have 1 GPU that's not acting right now, and I haven't had time to figure out what the problem is. So what I'll do is today we're going to implement this on DGX Spark. And you're probably wondering, well, Mike, you have a DGX Spark now. Well, remember, I built a do-it-yourself DGX Spark, right? A mini workstation. And I also said that when I built that, right, there were limitations to that. And the limitations were really around GPU memory. Now, that's really a lot of the limitation that you're going to see. Now, there's limitations, of course, in other areas, right? Speed, right, of token creation, time to first token, but video memory and video memory throughput and compute power are extremely important, right? I'm not going to get into, how inferencing works or how, the prefill and decode process works, but prefill is a very compute heavy task, and decode is a more memory bandwidth task, right, in the inferencing chain. Okay, and so when you're out there and you're looking at what GPUs I want to use, and again, depends on what your use case is. I'm not talking about for production. I'm talking about for testing, piloting, POCing, development, right? These are the use cases that I am engaged in, right? Now, when I go and at my day job and work for Nutanix, right, and I go out and I sell the value of Nutanix Enterprise A, it's really focused on enterprise AI. And so those other things, right, outside of, the dev use cases, the pilot use cases, POC use cases, right, then you really have to understand the architecture. You understand how inferencing works. You really need to understand how KV cache works. All these things, right, that happen during inferencing. Inferencing is very, very complex. A lot of people think it's just it's ChatGPT. right? And it's not even close to that, right? There's so many things happening when it comes to context and prompting and what happens with KV cache and the continuation of utilization of memory. What happens when you provide the context and system prompt, right? It goes through a pre-fill process, and then to get to the time to that first token, right? What's the decoding process look like, and what's important at those stages, right? Is it compute? Is it GPU memory bandwidth, right? And it's both, but it depends on what you're doing in the process. Okay. So, but in my my area, what I'm looking at from a DGX Spark perspective, right, is what's a good platform for me to test on, right? What's a good platform for me to actually run some piloting, do some fine tuning, leverage a large amount of video GPU RAM, right? Even though the bandwidth isn't great, leveraging the amount of tensor and CUDA core capability within the GB10 platform, right? And that's the reason why I selected to actually buy one. Now, I know you're probably thinking, well, Mike, you said you weren't going to buy anything for the home lab. Well, what I did was I sold my RTX 5090, right? I sold some things, right, to pay for the NVIDIA DGX Spark. So the DGX Spark is behind me right here in the little mini rack, right? That's coming with me when I move to Florida. We're actually going to go through a whole rack build, mini home lab build when I moved to Florida in mid-January and the following week. So when I go to Florida, that mini rack will be coming with me over here. You can't see it, but the DGX Spark is in that rack. It's very, very small device and very powerful for what it is. And I see a lot of folks on Reddit talk about how they're disappointed in the DGX Spark. Well, let me just tell you about the DGX Spark really quick, okay? It's a Grace Blackwell chip, right? The GB10. So basically it's an ARM an ARM compute solution combined with a Blackwell GPU. Okay. And it has 128 gigabytes of unified memory. Now, it's not fast memory. All right. It's not DDR7 or DDR6 or 6X. It's LPDDR5X. Okay. And so the memory bandwidth is not quite 300 gigabytes per second. I think it's around 280 or 280 something. I don't recall exactly, but it's not great. So when you're looking at the decode process, right, in inferencing, right, the amount of token generations is not going to be great because that's when you need memory bandwidth. Okay, so really it's about what can I use it for? Well, I can use it to pilot different things. I can use it to still create AI applications and point to multiple model endpoints. That's another thing this is good at. It's good at running multiple models simultaneously. Okay, and that's another benefit of having the GB10. Okay, in the DGX Spark. One of the other benefits is you can, if you decide to buy two, right, you can actually link them together. And there's a ConnectX-7 internal onboard NIC with dual ports. Each port has 100 gigabytes of bandwidth, right? So you can connect the two. Now, people will say, well, with 280 or around 300 gigabytes of memory bandwidth, do you really need 200 gigabytes of network bandwidth to combine two DGX Sparks? And the answer is yes. Okay. Now, I only have one DGX Spark, so I'm not using that. I'm only using the 10 gig port connected to my 10 gig switch and that little mini rack behind me. Okay. So what we're going to do today is, again, I had originally planned on deploying the NVIDIA search and summarization. Matter of fact, I already built the manifest. I've already built the documentation. I was going to review that with you. I was going to review the Nutanix platform underneath that this is going to layer on, right? And I was going to use Nutanix Enterprise AI to actually service the model endpoints for the VSS platform, okay? But what we're going to do today, because I'm having problems with GPU, is I'm going to show you what this looks like deployed on the DGX Spark, and then I'm going to talk about the various use cases for this specific application. And what I love about this application, it's not just okay, here's my video. Now I'm going to run it against a model to actually summarize the video. And I'm going to be able to chat against it. I'm going to be able to create alerts. Okay. But also, what does the ingest pipeline look like? Because anytime you're working with video, you're going to have to more than likely decode it. Okay, so you're going to need GPU resources just for that piece of it. So one of the reasons why I now have 3 GPUs in my NAI solution, I have 2 Nvidia Tesla T4s and one Ada Lovelace L4. Okay, and I purchased, I got a really good deal on another T4. I already had one T4, and I needed the T4s because there is decoding that is happening for the video in the ingest process of the video. So when I ingest the video, I need to decode it first, and then I need to run it against a search and summarization agent, right? And that agent will basically, I can create alerts, right? So basically, I can say, okay, here's a video of, or a live stream. This is another thing I want to talk about: a live stream of a video camera, maybe a traffic cam, right? And excuse me, an accident happens, and I'm a police officer and I want to investigate the accident. I don't want to go through all that footage. I don't want to have to scrub all that footage. I want to have AI scrub the footage for me. Okay. And basically, what I'm talking about is the ability to have AI summarize the video, and then I can chat against it. I can chat against the video. Okay. And I'm using a combination of embedding model and re-ranking models with this solution. Okay, and we'll walk through the deployment, what that looks like. And I'm also using a graph rag in the solution to make it much more effective when it comes to rag. Now, I'm not going to get into, I'm not going to get into what that means. We'll talk more about that in other scenarios, because I think when people think about rag, they automatically assume vector database, and that's not the case, right? There are different forms of rag. Graph is another method, and it's very, very effective. Okay. And I'm going to talk about those and the combination of using those two. As a matter of fact, in this demo, I'm using a combination of graph and vector. Okay. So really, what we're going to do is we're going to walk through the deployment on the DGX Spark. I'm going to show you a little bit about the DGX Spark first and how you can connect to it and how they make it easy. Okay, you already saw my do-it-yourself DGX Spark. Don't throw it. I still have it. It's still in the rack. It's still there, and I still will be using that. And I probably will repurpose it for a Proxmox virtual host down in the Florida house when I move in for the mini lab. Okay, because I won't need it to be a DGX Spark. I'll already have a real DGX Spark. Okay, so I go back to what I said last episode, though. You don't have to go buy a DGX Spark. They're very expensive. Okay, you don't have to go buy a DGX Spark. You can build your own for half the price, which I showed you how to do it. Okay, or you can use your computer that you have now. If you have a gaming GPU, like even a 5060 Ti, right, with 16 gigs of RAM. I say anything with 16 gigs of RAM or higher, you can do pretty good. Pretty good. You can do pretty good demos and testing and things like that. And the models are getting much better, right? I mean, I got to tell you, like, everybody's after these big models, right, with billions and billions of parameters. I'm thinking to myself, well, I understand why you want accuracy, but now we have these very good distilled models and very good models coming out of Nvidia as well, right? Using NVFP4 with little degradation in result. Okay, meaning that the difference between a quantized model, which is larger, say a floating point 16 or a BF16, right, model, to a NVFP4 model is slim. Okay, so now I'm able to basically get larger models, right, distilled, and still giving me, or quantized, and still giving me, right, excellent output. And I think that's kind of, I wouldn't say that's the future, but that's where it's going, right? The ability to, because if you think about it, right, the more parameters you have, obviously the more accurate you're going to be, but the harder the GPU works, right? Meaning the tokens per second get less and less, right? And the goal is to get as much accuracy and as much speed, right, to time to first token and how many tokens per second you're getting, right? And getting accuracy out of that. That's the true north, right? Because what you're doing as well as you're saving cost, right? Because now I don't need these massive GPUs, right? I might be able to just go with, RTX 6000s, right? 6000s in my enterprise environment. Maybe I don't need to buy that HGX with, massive GPUs, right? And memory. I can just go with an RTX Pro server and, maybe put 4 RTX Pro 6000, depending on what your use case is, right? And what your requirements are. And so if you think about it from an optimization perspective, Nvidia is even optimizing models, right? And Nvidia sells the silicon. So if you think about it, it's almost like the antithesis. They're kind of going against what they want to do. Obviously, they want to sell more silicon. They're a company, right? They want to make money. They want to make more revenue. But they're also helping out in a lot of ways around model quantization, model accuracy, model training. And that's what I love about NVIDIA. It's not just about the silicon. They're really looking at this from a platform specific use case, not just the GPU. The GPU is a portion of the AI platform from NVIDIA, right? And that's another reason why I went with the DGX Spark and not say we talked about Strix Halo, right? We talked about the Ryzen AI Max 395, where you could also get 128 gigs of unified memory. We talked about the Mac, right? The Mac Studio. I think the M3 you can get up to 512 gigabytes of memory, right? The issues with those are the frameworks on the back end. Okay, now Mac just released updates, and now you can cluster all these Mac Mini. But now you're up there in cost. Like the Mac Mini, or excuse me, the Mac with the 512 gigabytes of RAM is massive cost, massive. Now I know you could use it for other things, right? It's not just for AI, right? It's a workstation, and you could do all those other things. But it's like three times the cost of my workstation with a 5090, right? So even more, probably 3 or 4 times. So you have to look at this from a cost, price, performance perspective, what the use case is, etc. Okay, so let me just go to share my screen here. All right, so you can see my desktop. So let's talk about the video search and summarization blueprint. Okay, so unfortunately, this is a very long-winded. I like to actually go to the real one. So what NVIDIA has done under buildnvidia.com is they've actually, if you go to buildnvidia.com/Spark, if you have a Spark, this is where you can use, or they have a bunch of blueprints that you can leverage, right? There's a bunch of playbooks, blueprints, right? You can do Comfy UI, Llama Factory to fine tune, right? Fine tune with Nemo, fine tune with PyTorch. There's a RAG AI workbench. There's a lot of different demos or different use cases you can try on the Spark if it makes sense to you. You can even implement Olama into Open Web UI if you wanted, right? Just like I did on the do-it-yourself DGX workstation, mini workstation I did, right? So there's a lot of things you can do. It is, like I said, it is an ARM-based platform. So this is very similar to a real DGX, right? So imagine, you work in an environment where you build AI applications, and those AI applications eventually will be in production against a real DGX platform on the back end using ARM, using a Grace Blackwell platform, right? And now I can just take those, right, and port those over. I don't have to work on my Mac or my x86. I can port those over, right into the DGX production system without any refactoring. And so that's extremely important. Now, obviously in the DGX production system, you're going to have Kubernetes, right, from a orchestration perspective, and on the DGX Spark, you're basically using Docker, right? You're using with the NVIDIA Container Toolkit, right? Very similar to what I did on the DGX mini workstation that I built, right? It's the same tool set, right? Now there's other things, like they had this little connector. I'll show you this, that you install on your desktop, and then it comes down here, and now I have this connector, and I can actually connect into the DGX dashboard, a terminal, or I can use VS Code. In my example, I'm using VS Code, but there's also a dashboard here that you can see, right? So I can see what my system memory is, what my GPU utilization is, all of that. I can update it, right? I can see I can change the name. I can look at telemetry data, right, etc. I can go to docs, forums. So there's a bunch of links there. But essentially, what I'm really looking at is the utilization, right? And then, of course, you have the Jupyter Lab notebook. So if you wanted to start Jupyter Lab, you can start it. You can actually use a working directory, open in the browser, and then use the Jupyter notebook. You could do that as well. A lot of people do that. I don't particularly use the Jupyter to really use it, to be honest with you. I probably will start using it more now that I have it. But this is kind of a way to connect to the DGX Spark remotely. Now, DGX Spark is my rack. I'm on my workstation, and you're probably wondering, what happened to your 5090? The 5090 is gone, and I have I just took my gaming system. Again, I'm moving, so I'm selling a lot of things. So with the proceeds of the sales, I bought the DGX Spark, but I also have other things that were left over, like an RTX 5070 Ti in my gaming system down in the basement, and I just repurposed that for my workstation. Okay, and then that'll be coming with me to Florida. So again, I don't need a 5090 if I have a DGX Spark, right? And the 5070 Ti is a great GPU. All right, so let's open VS Code. So when I open VS Code, right, I actually also have a way of, I'm sorry, let me just make this bigger so you can see it. I also have a way of connecting remotely, right, to the DGX Spark. You can see here I'm SSH into my DGX Spark here. And you can see here I have my terminal session on the DGX Spark there. Okay. So let's go back really quick to the video search and summarization. Okay. Now, again, this is the DGX Spark deployment model. I'm sorry, no, it's not. This is the DGX Spark deployment model here. Okay, so I go back to buildnvidia.com, Spark VSS. Okay. There are basically 4 different ways you can implement this, okay? Because it requires 4 different model endpoints, okay? Not only that, it requires 4 different model endpoints for the full capability, and it requires GPU for video decoding, okay? So it is a heavy lift. As a matter of fact, I'm going to show you, outside of the Spark what it looks like in a minute, and that's the one we'll be using because I'm going to be doing everything local, and because I'm doing everything local on the Spark, I have to use specific models to fit in that 128 gigabytes of unified memory. Okay. So basically it walks you through how to do this. And then you have, I remember I said there's 4 deployment models on the Spark. There's actually, there's really 4, but they only give you 2 for the Spark for some reason. So for the event viewer, which gives you the ingest pipeline, right, and the video search and summarization, it doesn't give you chat against the video though. None of that, right? For the standard VSS, you get the ingest, the upload, the video decode, the search and summarization, the alerting, and then the chat against the video as well, which we're going to be deploying the standard VSS. Now it says here you need the video language model Cosmos Reason 1 7B. Okay. You need large language model Llama 3.1 70B. And I won't be using the 70B because I won't have enough GPU memory to do all of that. I need 2 models for embedding in ReRanker. There'll be the NVIDIA Llama models for that. And then the CV pipeline. Okay. So what I'm going to be doing is I'm going to be doing the standard VSS deployment. In order to do that, you skip to step 10, or excuse me, step 9. And it says here full local, and this is where it gets important. The full local deployment using smaller LLM Llama 318B is also possible. Okay. And that's why I'm going over here to do that. And if you go here, it has different deployment scenarios, right? You have the Jetson Thor, right, deployment. You have the DGX Spark deployment, and it tells you all the prerequisites on the DGX Spark. Most of these will already be done for you, right? CUDA version 13 will already be there. Docker will be updated. You'll have the driver 580 already. The DGX OS, right? I've already done the update when I actually installed it. And what's cool about the installation of that too, and just a little side note, is you can actually install it wirelessly too. I wouldn't do that, right? I did a keyboard and mouse. It uses Bluetooth, so you can hook up to Bluetooth keyboard or mouse, set it up, and then you can go headless, completely headless, which I've done. Okay. And then when I get to Florida, I'll have a Jet KVM connected to that. That way I can actually connect to it if I need to have direct connection to the console. You need access to Nvidia container registry. Okay, of course. Let me make this bigger so you guys can see it. If you are going to use remote model endpoints, meaning model endpoints that are going to be serviced through NVIDIA NGC, right? You need the NVIDIA API key for that. I will not be doing that. All my models will be running locally. So again, the Cosmos video language model will be running locally. The Llama large language model, which will use the 8 billion parameter 3.1 model, and the re-ranker and the embedding model will all be running locally on the DGX Spark. Okay. So we go to the installation overview. I'm sorry, let me just get out of here really quick. Let me go back to this. And now we're going to actually walk through the process of deployment. And you can do this right within here. Okay. So I'm just going to move this over to the other screen. You guys are not going to be able to see it. I'm just going to walk you through what I do here. So basically you have to log in first. I think I'm already logged in. Okay, I'm already logged in. It's login succeeded. So let me clear this to make this a little bit bigger. And now I'm going to basically export my key, create my local NIM cache, right? Because these are NIM models, right? And set up the Llama 3.1 8B instruct model for the DGX Spark. So we're going to copy this, and you can see this here, okay? And of course, I'm going to paste my API key there, and that'll allow me to actually connect to NVIDIA NGC, download the model if I need to. I will not need to download the model, I don't think. I don't think I removed it last time I set this up. But let me just bear with me a second. No. I have to clean this desktop up. Okay. I don't want you guys to see that because there's API keys there. So I have my NVIDIA NGC key here. Copy that. Let me just move this over here real quick. We'll paste that. And then we'll hit... okay. And then we're going to go back over to, and that's setting up, basically verify they have an LM endpoint at port. Okay, so let's do a Docker PS. Okay, now you can see. Now you see it went quickly because I've already downloaded the image, the Docker container image. It's already downloaded. So if what'll happen is, in your case, if fresh, right? Excuse me, you'll download the image and it'll store in the local image cache right here. Okay, so you can see here that this is coming up, and this Llama 318B instruct is basically up. Here I have a live LM endpoint at port. What will happen is when this comes up, it's actually not up yet. You'll see a box come up that you'll have access to port 8007, and it'll basically say, oh, okay, forward ports to 8007, and you can see that it's up. But in the meantime, we're just going to continue forward. So let's clear again. Yep, see? Oh, I must have lost my SSH connection. Let's see what happens here. I'm not sure what happened. Okay, let's clear out again. And now we're going to go back. Just bear with me a second here. Sorry about that. Okay. Okay, So the next thing we're going to do is employ the embedding model. The embedding model is the Llama 3.2 NV Embed QA 1B V2. Okay, it's another NIM model, and we're going to copy and paste this. Okay, and you can see here the Llama 3.2 NV Embed QA. Now you can pause here, on the video when you watch it back to get the actual commands. But essentially, what we're doing here is we're basically deploying the models required for this actual application, right? So we've already deployed the large language model, which is the Llama 318B. Now we're deploying the, oh boy, hang on. Now we're deploying the embedding model, okay? Sorry about that. Here, let me try this again here. Let me get my key. Let me paste my key. Clear Docker PS. And now you can see this embedding model is starting up, okay? Next is we're going to deploy the re-ranker, which is another NIM. It's Llama 3.2.nv-re-rank QA 1BV2. Let me get the key again. Copy, paste, clear Docker PS. Okay. Okay, so now that those models are up there, okay, we're gonna go into the directory. Okay, so this is the directory I use. I'm gonna have to make this a little smaller so I can work with it, unfortunately. I apologize if you can't see it. Let me clear here. So this is a directory that I use when I actually clone the Git repo. I wanted to use this. And so we're gonna go into the local deployment single. So if I do an LL here, you'll see, let me see here. Yeah, so under Docker, so under basically the video search and summarization deploy Docker, what you'll have is local deployment, single GPU, remote deployment, remote VLM deployment, right? So you have these different deployment methodologies where you can have a full local deployment with multiple GPUs. You can have a local deployment with single GPU, which is our case, right? Because the Nvidia DGX Spark is basically one GPU with unified memory. And I have remote LLM, remote VLM. So don't worry about those and don't worry about the local deployment. What you're going to be worried about really is using the single GPU, right? So we're actually going to CD into that. Now that we're there, now we're going to look at the config YAML file. Okay. In the config YAML file, what we're going to do is we're actually going to go into the ingest, looking for the ingestation function right here, which I'm at right now. And under params, you have disable entity extraction true. This will be commented out. Okay. What we're going to be doing is we're going to be uncommenting this for the DGX Spark, because that's one thing we have to do. Okay, so that's already done. So we're going to get out of there, and now we're going to VI into the .env file, and we're going to go down to ngc API key, Let's go back up. It's already there. I've already put that in. So you have to put your NGC API key in there. And then you're going to have to go down to the VLM parameters. Okay. And this is extremely important for the DGX Spark because of the memory capacity. Remember, we're actually leveraging this. If we go back to the dashboard, you can see the memory being used, right? When we start these up, you'll see this all being used. And so this will go up all the way to like up here. It's crazy how much memory we'll be using because we'll have 4 models being used. And so you want to make sure that the batch size is 32 and the GPU memory utilization is 0.3. And those are default, by the way. The only thing you really have to put in is the NGC API key. Everything else is pretty much set for you. So let's get out of that file now. And now what we're going to do is, after you set up the API key in the environment file, you can launch VSS with Docker Compose, okay? So what we're going to do is we're going to do a CD back here. We're going to do an export ISSBSEA equals 1. And we're going to do a Docker Compose up. Oh, wait a minute. Unfortunately, I went too far here. So let's go back to CD demos, ESS, video search summarization, deploy, Docker, local, deployment, single. Let's do this again. Export ISSBSA equals 1. Docker compose. Okay. So now we're going to wait for this to actually get up, and it's actually bringing the actual whole application up. And you can see here your application is running on all these ports will become available. What we're really concerned about is 9100. So 9100 to the DGX Spark IP address. All right, so that's where the UI is. And so when this is done, we'll actually go to the UI for DGX Spark. And let's check and look at our dashboard. Let me refresh this and see. Yeah, okay. So you can now see the memory's increased quite a bit. All right, let's see if this looks right. Via server loaded. Is that up yet? I don't think so. Backend is running. Okay, so what we're looking for is on this Via server -1, we're looking for backend is running and front end is running, right? Front end is running on localhost, right? 0.0.0, colon 9100. That's what we're looking for. Now, remember when I stood up those models, right? All those models will download for you, right? If you're just doing this, or if you just did this on a new machine, or you're doing it on a machine that has a larger memory footprint. You can see here the memory footprint. At the end, when this is done, I'll show you the memory that you're going to basically need. Right? Look, we're already at 70. We're climbing in memory, right? So you have 4 models running. You have the Cosmos 17B, so it's 7 billion parameter video language model. You have the Llama 3.1 8B, 8 billion parameter large language model. You have the re-ranker, or the embedding model, Llama embedding, and the Llama re-ranker. That's 4 models. And then you're going to need video memory and video capability for the video decoding process. Okay. And so you can see here ramping up here. And by the way, this is like similar to, we're going to do a whole session on the comparison of, okay, so when you buy an AI factory, so let's assume that you're in the enterprise and you've actually deployed it, or you're actually looking at AI factory. Like, what does an AI factory look like? Well, an AI factory is essentially a reference architecture with a partner. Let's assume it's like Dell or Cisco or whatever, right? Each have their own benefits, by the way. I'm not saying that Cisco doesn't have benefits and Dell doesn't have benefits. So, and we're pretty much almost done here. But essentially, going back to what I was talking about with the AI factory, there really is no simplified way to actually have model operations. Okay, and I know model operations is kind of this loaded phrase, but if when you think about it, right, you're going to want to have in an enterprise environment, you're going to want to have complete operational control over models, right? Who has access? Who can download? What models are you can download? Um, what applications can communicate with specific models? Um, what model versioning, right? As new models come out in version, or if you're fine tuning your models, you want to version those, right? And you're giving full life cycle around model operations for inferencing, right? And that's what you don't get with any enterprise AI factory. Okay, you don't get that with the Dell Enterprise AI Factory, even though Dell has scripting for blueprints and all these things, right? It's essentially Dell's hardware, accelerated compute with your storage stack, and then you plug in your Kubernetes, right? Right, your Kubernetes of choice, and then they on Kubernetes they layer in right the Nvidia AI enterprise software. Now that Nvidia enterprise AI software is like the scaffolding. Let's assume like if to make this very simple from an analogy perspective, the Nvidia enterprise AI software brings you all of the top tier um, components. Let's assume you're building an AI factory. Okay, when you build the AI factory, you start with supplies, right? You have this foundation, you have the supplies, the building supplies, the walls, the foundation, the framing, the plumbing, the electrical, all of that for an AI factory, right? Now I know what you're thinking, well, an AI factory isn't literal. Well, it can be, but I'm just using an analogy. NVIDIA brings all of those supplies and then lays them down for you, right? Here's all the supplies, right? We can build this in kind of this fashion where it's you have to kind of build, you have to kind of be the contractor, and you kind of have to build it yourself, or you have to hire a bunch of people to come in, experts to actually deliver services to make it basically consumable, right? So you we're not quite used to this in the enterprise, right? The iPhone way, right? Where it's just, oh, the updates work. I take a picture, the pictures go to the iCloud, et cetera, automatically. I don't have to worry about it, right? But we should be getting there. We should be making it easier for the plumbing, the delivery of platforms, and all of that, the life cycle of platforms. That should be front and center to what we're delivering in the enterprise, because the other side of that is consumption. You've heard me talk about this before if you watch my blog posts or read my blog post or watch my podcast. The other part is really about consumption, and that's where value begins. Value doesn't begin at, oh, I purchased Dell AI enterprise AI factory. Value begins when that's implemented, it's operationalized, and now I can consume, and AI apps are actually consuming that. That's where the value train begins, right? And so we should be making sure that those things are very easy, right? Are simplified. And that's what Nutanix Enterprise AI does within an AI factory. So when you have all the scaffolding and all of the pieces components, Nutanix Enterprise AI, along with the Kubernetes platform, brings that all together in a simplified fashion so you can deploy your model endpoints and you can consume. And that's the beauty of it, right? That's what's missing fundamentally from any AI factory, whether it's Dell's, Cisco's, HPE's, whatever, right? There is no model operations within those platforms unless you do it manually. You see what I did here? I did some Docker commands to actually deploy this, and then it ran a script to deploy it, right? there are blueprints that Nvidia provides within Nvidia AI Enterprise. Okay. The problem with that is I have to take that and I have to make it production grade within Kubernetes. I have to build the observability stack around that. I have to build the model endpoint repository. How do you manage that? You have no visibility into that other than going through some declarative operations, right? And some storage. So how do you monitor that? How do you make sure that only this user can access? How do you limit or throttle, right, connectivity to the endpoint, right? How do you do any of those things? And you can, but you have to build it. And so that's the problem with the AI factory model today. And so Nutanix solves that by coming in and being the contractor and building it for you, right? And that way it's very easy to consume and operate. Okay, so I went off on a tangent, but what you saw me go through to deploy this, you're probably thinking to myself, well, that was easy, Mike. It's easy because it's not production ready, right? This is not production ready. Can I get to it and access it? Certainly. And we're going to do that in a minute. I'm going to show you what it looks like. But does it have observability? Does it have security? Is there network security around it? Am I managing my models other than having a Docker container and storing it locally in that NIM cache? Is it versioned, right? Can anybody access the UI, right, to get to that model endpoint? Yes, right? So it's not production ready is my point. And so the way I've deployed this is just to get a demo working to show you the functionality of VSS, but it's not a production deployment of VSS. And I'm going to show you what that looks like in the next segment when I get that GPU fixed on the Nutanix Enterprise AI platform so you can see what that looks like from a production ready platform. Okay, so hopefully this is up and running. I didn't see the... And I'm not sure if this is working. I had it working last time. Let's just try it. Uh, 192.168.10.104. Okay. So it looks like it's working. Okay, so this is basically the UI for the Nvidia search and summarization agent. So you can do images, you can do live stream, and you can do video files. So what I like about this is Nvidia includes a couple videos in here. And so I think one of the ones I want to show you is the warehouse video. Okay. So this is a real video, as you can see it playing. Okay. And essentially what I'm going to do here is I'm going to stop playing it. And I'm going to summarize it. Okay, so right now you can see it's processing the video and it's going through a summarization. And if you go back to the terminal, you can see what's happening here. It's batching it, it's chunking it, so it's embedding it. So it's going through the RAG process, right, of embedding. And you can see graph RAG is being used as well here. And it's going through that process. And then it's going to give you a summarization of what happened during that video. Okay, so imagine the power of that, and it takes a little bit because again, it's got to go through the entire video. This video is 3 minutes and 30 seconds long, and essentially what we're doing here is, again, it's chunking the data, embedding it, it's using graph, right, to do the embedding, and it's going to then go through and summarize the video for you. And then we'll be able to actually look at how we can create alerts, why that makes sense to create alerts, and then ask questions against the video itself. So basically chat with the video file, okay? And that's pretty important. So you can see here it's done, and it gives you basically a summary of the video. So between 0 and 120 seconds, this is the first chunk. Now it's chunking it, right? It just says a man wearing a yellow safety vest and green shirt enters the scene carrying 2 boxes. He placed the box on the shelf, blah, blah, blah. I'm not going to go through all these things, but essentially it went through, did the processing time, of 74 seconds, and the stream duration was 210 seconds, right? So that's the video time, 3 minutes 30 seconds. Okay. Now you can also create alerts, right? So if I wanted to basically create an alert, I can go down here and I can actually create an alert name. Okay. And say, okay, show me, create an alert for a person in a warehouse not wearing a safety helmet, right? So one of the SOPs in a warehouse is you always have to have boots. And if you're around things outside of the line or whatever, you may have to wear a safety helmet, right? And you can see here this guy's not wearing a safety helmet. So maybe I say, safety helmet, right? And I say add an alert, and I say helmet no helmet save, right? And maybe that kicks off an alert when it goes through the summarization. And that alert can be sent to a system, right? And you can get something like right away. Or imagine that you are looking at a live stream of the entrance to your building, and an employee comes in and badges in, and then another person comes right behind him. They leave the door open, and he comes right in afterwards without badging in, and that's a safety concern. That could be a security problem, and you see that on a live stream summarization. Right, I can do an RTSP, right to a camera and do live stream and have the alert go right to my guards. Right, so think of the safety that can, and the security possibilities. Another use case I was thinking about for this is, what about like, let's look at a real use case, right? So the FBI just identified and captured the January 6th pipe bomber, okay? And they had probably hours and hours and hours and hours of video footage. So now I don't know if they have a system like this. I'm assuming they have something like this, okay? But for your average police department or city police department, and if you're a crime show watcher like I am, okay, sometimes you'll see them go through hours and hours of video, taking days, weeks to go through all the video footage to find something, right? Um, that's that's important to the case, right? Like, find me a red car, right, with its license plate, or find me a person that looks like this that was wearing XYZ in this video footage, and then have AI go through the video, right, and pull that data out for you without having to go through every minute of video, right? So, for example, if I go back to here and I go back to chat, I can ask the chat now, was there anyone that was not wearing a safety hat? Okay, so now I'm asking, yes, there was one person who was not wearing a safety hat. The individual in the first scene wearing a yellow safety vest and a yellow cone was not wearing a hard hat. Okay, so think about the implications of this, right? Of how you can make things safe, avoid accidents, how you can get to case closure, how you can be more secure in your environments, right? There's just a lot of different use cases you can see being used for the video search and summarization agent that is tied into this. Now, one thing you can also do is I can actually upload a video, right? And I don't know, again, this is kind of a large video. So this is a great example of a video, right, where, okay, where I had workers that were working. This is a real video where I had workers working in my home in Florida, which I'm moving to, getting the house ready to be moved in. And the worker called, or the guy who was in charge called and said, hey, someone bashed your door here, okay, and opened the door and made a hole in the wall. And maybe it was the Home Depot guy, okay? But I pulled the video footage from my cameras, and I had to scrub through all that video footage. So this happened on the 14th of December. So that hole in the wall that's here that you can't really see right here was made December 14th. And we got a call about it yesterday on December 26th. Okay. And he said, hey, it looks like one of the, maybe the Home Depot guy who delivered the equipment or delivered the stuff put a hole in your wall. It's going to cost XYZ to fix it. And I said, that doesn't sound right. So I went back and looked at all the footage, and I found this video of one of his workers, right? You can watch it again, opens the door and slams the door into the wall, right? And that caused the hole. So now we can go back and say, well, you did it, right? Now, it took me 30 minutes to go through that, 40 minutes. Imagine if I were to upload all my video footage into this video search and summarization agent and then ask the question, find me a person who slammed the door and made a hole in the wall. And it comes back and says, yeah, there was a person that happened at this time on this date. I just saved 30, 40 minutes of scrubbing through footage, right? That's what I'm talking about. There's value in that, right? Or if I had a live stream of this video, as an example, matter of fact, let me see if it will summarize this, because it is a large file. Let's see if it'll summarize it. I mean, it's only 21 seconds, but what I find in the video files that you use for something like this, FPS matter, right? So basically, here we go. Summary events: man walks towards the door, back in the frame, holds the broom in his right hand. He wasn't holding a broom, by the way. So this again goes back to the model you're using, right? That's extremely important, right? So there is some hallucination in this model. Remember, we're only using Llama 318B. If I was using the 70B, or if I was using the new Nemotron model or GPT OSS 120B, it would be much more accurate, right? Close the door behind him. Then he didn't close the door either, right? Door slightly ajar, comes as known person. Okay, so it's giving me. Let me see if I ask this a question. Did the door slam into the wall? Yeah, see, it's not reasoning. It's the model I'm using is not the right model for this. This again, the model we're using is Llama 318B, and the only reason I'm using that is because I only have a certain amount of GPU memory, right? But if I was using a much better model, it would tell me, yeah, it's slammed, right? Because it would see it. Now, there was a hole in this right here where my mouse is here, and that's where the hole was. And he actually also broke the doorstop, right? And probably damaged the door. So now I know that they did it. But again, it took me 30, 40 minutes to go through all the footage from going back from yesterday all the way back to the 14th, right? And now if I had this video search and summarization, I could have uploaded all that video, had it summarize it, and then ask a question. Did you hear a door slam, or did you see a door slam into the wall? And at what time, what day? And it would tell me that. And I could just go right to that video file. So that's the power of VSS, right? Video search and summarization. And it's running on DGX Spark. Again, not production ready, right? What I want to show you next is running the same process, the same application on the Nutanix AI platform to show you what it looks like to get to production readiness, how easy it is to deploy the models and manage them, right? And basically give you an idea of what this looks like in a real production system, okay? So again, this is long-winded, I know. That's about an hour, so we're right at time. And again, I know I promised you guys this will be running on Nutanix platform. Unfortunately, I have to figure out what's wrong with the one GPU I have. And when I do that in the coming days, hopefully next Saturday, in the next episode, we'll walk through this running on the Nutanix Kubernetes platform. I can actually deploy it and get to this page, but I don't have enough video to actually decode the video, or GPU to decode the video, so it's useless. So you'll see this, and you'll see the ability to play a video, but you won't be able to process the video, right, and go through a summarization process, okay? All right, so I hope you have a great rest of the weekend, a great new year. You're getting well-needed rest, and I look forward to talking to you guys about this application running in a production ready platform and having it be production ready, right? And I'll share with you the manifest, the documentation, and I'll actually send it up to my GitHub, and I'll share that out via GitHub so you guys can actually leverage this on your environments, right? Whether it's demo or in a real enterprise AI ready environment. So have a great rest of the weekend. I look forward to talking to you soon, and have a good one. Bye bye.